Hi friends, welcome back. Today we are going to discuss more about very fundamental and very important question about core Java. This is regarding why do we need to override the equals and hash method, right? So this question is very important if you are junior developer or mid-level developer or senior developer, right? So because this is a very conceptual and very fundamental question that you should know, and this is also invariably asked in many interviews because that test, if you know the basics of the language or not. So make sure you watch this video until the end because this is going to be an important video, so that you can completely understand the concept behind these equals and hash code methods, which are one of the basic things for Java developers, and very important thing that from the coding interview perspective, right? You should know why we have to implement those methods basically, right? And in which case it actually matters. If we don't implement those methods, then the results will not be correct basically, right? So make sure you watch this video until the end. So I'm going to explain you why we have to implement both these methods and why these methods are very important basically. Before we start discussing more details about this, I want to mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 400 different varieties of solved coding problems, which are pretty much like asked questions in the past by big tech companies, including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, LinkedIn, Netflix, Uber, Lyft, and many other companies. You will find all important coding questions varieties on this channel, including breadth first search, depth first search, graph problems, matrix problems, coding questions related to binary search trees, binary search related coding problems, string problems like LinkedIn related coding problems, optimization problems, dynamic programming question, and lots of logical questions. So if you go through those videos, you are going to learn a lot here. You will be learning a lot regarding Java programming, data structures, algorithms, and how to solve different varieties of coding problems using different algorithmic techniques. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you are simply interested in learning Java and different important concepts, then this channel can definitely help you in doing so. So please subscribe to the channel now. Also, whenever we come across any interesting important coding problems or concepts, we create videos to discuss those things so that we can also help people in their coding interviews or in general interview preparation, so they can learn by watching these videos different things. So make sure you click on the bell notification icon so you won't miss any important forthcoming videos on this channel. So let us start with this discussion of why to override equals and hash code method, right? So both these methods are in the object class in Java, right? So and what happens if we don't override these methods, right? So they will ask in the interviews that why do we need to override these methods? What will happen if we don't override these methods, right? So first we will understand what these methods are actually. So if you go to the object class, right, this is the documentation from Oracle site regarding the hashcode and object like equals method, right? So this is the object class, very important, the basic class in Java, right? It's in java.lang package, and as you can see, this is the root class of the all class hierarchy. So this is the root class basically, right? Everything extends from the object class, and it is from the Java 1.0 basically, right? And all objects including arrays implement the methods of this class. So now let us take a look at the hash code and equals method, right? These are the two important methods that we want to talk in today's session. And why do we need to why do we need to worry about these two methods? What is the importance of these two methods, right? Excuse me. So we'll first take a look at the hashcode method. So the hashcode method returns the hashcode, right? So we know that hashcode method returns the hashcode. But what is the important thing about the hashcode, right? So let's just read what they are saying first. So returns hashcode for the object. This method supported by benefit hash tables as those provided by hashmap, right? And in general, contract of hashcode is that whenever it is invoked on same object more than once during execution, it must return the same integer. So it must return the same hash code basically. Even if you like invoke this hash code method on the same object multiple times, you should always get the same hash code. But you are provided you have not changed the values of any of those fields of the object, right? So this is one important thing. And if two objects are equal, right, according to the equals method, then calling hashcode method on each of the two objects must produce same integer result if two objects, different objects are same basically, right? So for example, if I show you two different objects, these are two different objects, right? But both are equal objects. Both have, let's say student is a class, it has a name and it has a ID, right? Now both these student objects, both are different objects, but both have same values, right? So they are equal objects. So they should result and produce same hash code. That is what they are saying, right? And so that is an important thing. And they are saying that the two objects, if they are not equal, then it's not necessary that they will not produce the same hash code. If they are different like unequal objects, right, they are not equal objects, they may produce the same hash code, right? So that's what they are saying. So that is what this last thing is saying. So as much as reasonably practical, hashcode method defined by object does return distinct integers for distinct objects, right? Because that will benefit basically for, like, as you can say, they are saying that this is typically implemented by converting internal address of object into integer, but this implementation technique is not required by Java programming language. So this is a hashcode method. So now you understood what the hashcode method is, right? So we know that main thing is two different objects are there, but they are equal objects like this, right? They have same name, same values, like IDs, right? Then they should produce same hash code. So that is an important thing. Now equals method. Let's read about equals method, right? So this is the equals method. So this is another very important method. These two methods, why they are important, we are discussing. So indicates whether some other object is equal to this object basically, right? So the equals, so this is where they are talking more about how the, like, they are reflexive, transitive and symmetric in nature. Those things actually you can read it later, but the important thing is the equals method for class object implements most discriminating possible equivalence relation of object. uh, so basically what they are saying is, if you have, let's say, this kind of two different objects, right, they have same values for their fields, right? Name is same, here also name is Amit and ID is same, right? So they are basically two different objects, but they are equal objects basically, right? So now, this is what they are saying, and they are talking about more of a transitive nature here. So if one object is like x is equal to y and y is equal to z, then x is equal to z, right? So that is what they are talking about. And if x is symmetric, means if one object is equal to other object, other is object is also equal to the first object, right? Second is equal to first. So so now let's go back to our original question. So in the question, mainly they are saying that why do we need to implement these both methods? What is the need for that, right? So the need for that is, so there is a contract basically, right? There is a contract. So whenever you have two equal objects, they should always produce a same hash code, right? So that is the main contract. So these are the two equal objects, so they should produce the same hash code. But how will we know that they will produce the same hash code? So for that we have to implement the hash code method, correct? We have to implement the hash code method. For example, this is the class that we are talking about, right? So this is just a sample class that I created to show you. So it has two fields, one is ID, one is name. So now this is a student class, right? So student ID, student name is there. So now we are here implementing the equals method here, right? We are implementing the equals method so that we can check if two different student objects are equal or not. So if you look at this method, how we are implementing this equal is, if this is equal to object, right, means the current object and this object are pointing at the same location, then we'll return true in memory, correct? If the object is null, this is null, then we'll directly return false. Otherwise, what we check here is the class. Both objects should have the same class. If their class is different, then we will return false. For example, if This object class is a student class, and if you are comparing it with employee object or a employee class object, then we will return false, right? Because both classes are different, right? Otherwise, we will convert this object into a student object, which is other, and we will compare each and every field of this class, right? Each and every field, ID and name. So how we are comparing? We are checking if the ID of this class and other class, other student is same. If they are not same, we will return false. If name of this class is not, if it is null, then other name also should be null, right? Correct? Now name of this class and other name are not equal, then it means that they cannot be say equal objects basically, correct? So we'll return false. If we reach here, it means that we have checked all the fields of this class with the other object and everything matched. So it means that both objects are equal, right? All the fields we have checked. For simplicity, I have just shown you two fields here, ID and name, but in reality, in practical uses, you will have maybe 10 or 20 or 30 fields also. So we have to check each and every field there basically, right? For equality. This equality is important. So we are coming there why we are implementing this. I am explaining you in a minute, but this is important. We are just going through and I am showing you how we can implement these things, right? Now hashCode is another important method we have implemented here. So hashCode, we will start with a prime number, right? Any number you can take, prime number 11 or 7 or 31 or 23, whatever you want to take. Then what we are doing is we are multiplying this prime with the this result, and we are adding these numbers, like adding these fields basically. Like here it is ID, we are adding ID here, then we are adding again multiplying this prime into result and adding the hash code of name, right? Name is a string, so we will use the hash code from string class here. We are again adding it to this like this result, right? And we'll return this result. So we are calculating the hash code. Now this hash code, if we, why we are using prime number? So that it can generate distinct hash codes for different objects, right? The prime number is, that is why we have used it, so that it can, for different objects, it should give us so different hash codes, right? Because the concept of hash code is very important for the hashing, right? Hashing is used in the hash map, hash table, tree map, all those classes of mappers, right? We will use this hashing concept. Excuse me. So now you understood what we are doing in the hash code and how we have implemented hash code and equals, right? So now let us talk about what happens if we don't implement this. Now what we will do to understand why we have to implement these methods is we will create two student objects here, right? These are two student objects. So this part I will just comment out for a minute. We will go there in a after some time. So now we have two student objects. Both are equal objects, right? You can see same name is there and ID is also same here, right? And we will print the hash code here because we have a method here for hash code, right? So it will print hash code, and then we will check if both are equals or not here, correct? And then we will create a set of students and we will add both of them into the set, right? And we will print the set here, right? Now since we have implemented equals and hash code, the set knows that these are actually same object. These are one object, not two different objects, right? So when you print the set, you will only see one entry there, right? Because set will hold only distinct objects, right? So now let us run this and I'll show you that it will only hold one entry, right? Because we have actually implemented both these equals and hash code method, correct? So now let us see, let us execute this. So as you can see, here we have printed the hash code of both S1 and S2. As you can see, we are getting same hash code, right? Two different objects, hash code is same. This is why we are getting, because we have implemented this hash code method. That is why we are getting this basically same hash code, right? And we have the equals method, that using which it can tell us that these two S1 and S2 objects are equal objects basically, correct? And then we add these two objects into set, but they are equal objects, so only one object you will see into set. Why we are seeing one object? Because set will only hold distinct objects, right? Distinct objects. So you are seeing only one object here, correct? So far clear, right? That we created two objects which are equal object we added into set. Now what we will do is I will show you one thing now. Let us remove this equals method. Okay. So let us just remove this equals method. So now we are not using any equals method, let's say, right? Now we will again run this code, and now I will show you that the set will contain two objects now. Even if they are equal objects, the set will treat them as a two different objects because we have not implemented that equals method. So there is no way for the set to understand that these are actually the equal objects basically, right? Because we have not implemented equals method. So now let me again show you that. So now as you can see, the set is having two different objects. This is where we are printing the set. Now you are seeing two different objects are there now in the set, right? Because set does not know that these are actually equal objects because we have not implemented equals method. That is why we have to implement that equals method, right? Whenever we want to use these collections like set, hash map, right, then we have to implement both these methods basically, otherwise it will not work as expected. So always remember that whenever you are using those objects inside the collection such as set or hash map as a key, right, as a key, then you have to implement both these methods, otherwise they will not work correctly. Correct. Now one thing I wanted to show you is now what happens if we don't have the hash code also, right? Now, right now you are seeing that both hash codes are coming same, correct? Why they are coming same? Because we have implemented this method, right? This hash code is coming because of this method. If we remove this method, right, the code will still work, but it will not give us correct result. So I will show you now the even if these are now this is actually equal objects, both are equal objects. Now let us put the equal method back, right? So now we have equal method, but we don't have a hash code method now, right? So now equality will work. Now now the set knows that they are actually one object, so it will have only one object now because we have implemented equals, but we did not implement hash code method. So when you print the hash code will be showing different result. Now let us try. So as you can see, hash code is coming differently, right, because we have not implemented hash code methods. So even if they are equal objects and they are giving us different hash code, this is a violation of contract basically, right? This is a violation of contract. And also actually for a set also it is not working correctly. It is giving us two different like two objects into the set, right? Now why this is happening? Because we have to implement both these methods. Hash code should be also there and equal should be there. Now if we implement both these methods, you will see that the now you are seeing two different like two objects here inside the set, right? So now we will execute this code again, and now you will see that after we after we implement both equals and hash code here, you will see that only one object will be there now, right? So let us try that. So as you can see, this is what is the correct result, and this is what should happen basically, correct? Because these are same objects, equal objects basically, right? So you should get only one entry into the set. Now you are getting one entry, you are getting correct hash codes also, correct? And you can do the equals also working correctly for you, right? Because you have implemented equals method, right? So I hope this is clear to you now why we have to implement both these methods. Because if we don't implement it, we will not get the correct result, right? The code works, but it does not give correct results, right? So, and there is a contract basically that when we have two equal objects, they should always produce same hash code. That is a contract basically of the object class. If you read here, right, I'll just show you that quickly. If you just search here for contract, right? Yeah, so see, the general contract of hash code is that if two objects are equal according to equals method, then calling hash code method on each of the two objects must produce same integer result. Means they must produce same hash code basically, right? So when it will happen, when you have to implement that hash code, correct? You have to implement the hash code. If you don't implement, it will not work basically, right? So when you are planning to use those objects inside a set or inside a map, then you have to make sure that you implement both these methods. So this is not optional in this case, right? This is not optional. If you want to use this inside set or inside a map, then this is not optional to implement. You have to implement these methods, both equals and hash code, right? So as the original question goes here, uh, why do we need to implement? So you can tell them in the interviews that there is a contract that two equal objects should produce same hash code basically, right? In this is in Java object class, right? So to follow that contract, and when we are planning to use those objects inside collections such as set or map, right, like as a key in key as a key inside the map, right, then we have to make sure that we implement both these methods. Otherwise it will not give correct results, right? So that is what you should tell. And if they ask you what happens if we don't override these methods, then you can tell them that we will not get correct results basically, correct? So now I will show you. Now we have seen this first part. You understood this first part clearly. So now I will show you the second part. So what happens if we use these student objects as a key objects, key in the map, right? Then what happens in that case? Let us take a look. So let us comment this code. So this question is extremely important for any level of Java developer jobs you are trying. You should know this basically, right? If you don't know, this is a basic thing that everyone who is trying for any Java roles, they should know. This is the most basic question and fundamental questions, right? Because you can just imagine that you are writing a code without these two methods and you are using it inside the collections like a set and map, then it will not work correctly, right? So now let us go with the map example. So what happens inside the map? So now we have actually created two student objects. These both are actually equal objects, right? As you can see, these are equal objects. You can even try this equality and it is printing that both are equal objects, correct? Correct. So now what we are doing here is we have a map which is key is student and string is the department of that student basically, for example, right? So now when we have a proper code, like when you have implemented hash code, when you have implemented equals, correct? Now you implemented correct code, and when you are putting S1 here, right? And you are assigning a computer science department to that student one, right? When you are putting S2 here, when you are saying information technology department for this student, right? Now map knows that this S1 and S2 are actually the same object basically, right? These are equal objects. So what it will do is it will overwrite it, right? It will not create two entries into the map. It will only create one entry into the map, right? So this is two different objects here, S1, S2. When you put a map, like this is our map, right? Hash map. So when you make one entry here, you have implemented equals method, you have implemented hashcode method, you put one entry here, right? S1, and you are saying that computer science is the department for S1, right? Now you are putting S2 and you are putting information technology for that, right? So this is just a key, right? This is just a key. So what it does is, if you have proper implementation of equals and hash code, what it will do is it will actually override this entry with this new object and it will put information technology here. So you will have only one entry into this map basically, right? Not two entries. Why it is doing it? Because this is actually equal object and key are basically, key should be distinct, right, into the map. So this is how it will be, it will overwrite it basically, right? And this is a correct behavior, that it will overwrite it. This is the correct behavior, right? And this is working because we have implemented both equals and hash code. We are telling the map how to actually equalize, like how to equate this key, right? That this S2 is actually same thing as S1, right? Because equals method we have implemented, that's how it knows, right? And other thing is, when it has this object, it knows the hash code, right? So for S1 and S2, the hash code will be same basically, right? Because both are actually equal objects, and both two equal objects always produce same hash code, right? So what map does is, it is a bucket for map, right? It is a bucket, so key is a bucket, so it will go to that bucket and it will overwrite it with s2, right? So now s1 get overwritten by with s2, and it will overwrite the value with information technology, right? And why this is working? Because we have implemented both equals and hash code method correctly. So I will show you now that. So this is the one that we will try. Now when you do map.keyset, it will actually iterate through the current map. So now you will see that only one entry will be there into the map, right? It will only give you s2 because it get overwritten. S1 entry got overwritten here. Why? Because s1 and s2 are equal objects. So let me show you that. And this is the correct behavior, right? And this is correct because we have implemented both equals and hash code. So now you can see that s1 equals s2, both have same hash code, and you can see that actually you have printed the value here, right? You have printed s map.get s and to string, right? So you got information technology, and this is a correct behavior, as I said, because these two keys are not separate keys, it is the same thing basically, so it will overwrite it. Now what happens if you don't implement the equals and hash code? Let us see that you have a equals method but you have not implemented hash code method. Then in that case it will get another hash code here, correct? So what happens, let's see. So now I'll just remove these things. Now you have this first entry you added, s1 is computer science department, you are putting s2 with information technology. Now s1 and s2 will generate two different hash codes, right? This is hash code 1, this is hash code 2. So what map does, it will put this object into the bucket according to the hash code. So hash code, it will create another entry here for s2, and it will put information technology here, right? Which is not basically what your intention is. Your intention is that these are actually equal objects, so it should get overwritten, right? Because this is a key, right? This is the key in the map. If it is a equal object, it should get overwritten, but your hash code you have not implemented, so it is producing two different hash code, right? So it will create another entry into the map. So I will show you that. Now in this case it will print both computer science and information technology here, right? Right now it is only printing information technology, right? Because there is only one entry in the map. Now let us re-execute this code without the hash code method. So now you can see that there are two entries in the map now, computer science and information technology. So this is not what you wanted actually, right? So, and this is happening because you have not implemented the hash code method, right? So you have two equal objects having two different hash codes. I am showing you the hash codes also here. Both hash codes do not match, right? So that's why you have two different entries inside the map now, right? That is why you have to implement both that methods, correct? So now you understood why we have to implement both the method, right? So now let's put our hashcode method back. So this is what we used to have, right? Now let's say we implemented hashcode method but we did not implement equals method, right? So this is also wrong. Basically you implemented hashcode, which is a good thing, but you did not implement equals method. So what happens again, it will create two different entries, because now the map does not know that these two s1 and s2 are equal objects, because you have not implemented equals method. So it will consider that they are two different objects, so it will create two different entries into the map, right? Right, that is why it will create two different entries. So you have to implement both those methods. That is why you have to implement those methods. So now let us run this code without equals method, right? So now you can see that you got computer science and you get information technology. Both are actually giving the hash code is correct. You have two objects, you have same hash code, but you did not implement the equals method. So because of that, the hash map does not know that these are two equal keys basically. So it is treating them as a two different keys. So it is creating two different entries inside the map basically, correct? So that is what the problem is now, right? So as you can see here, it printed two entries. Now let us go back and put all our methods. These are our correct implementation. Now we implemented both equals and hash code here. So now let's rerun this code now. Now it should produce only one entry, information technology, because this is the correct way of implementation, right? So now it has produced only one entry here, information technology, because it know that it is actually a equal object. It will override this object with s2, right? It will overwrite it with s2 and it will change its value with information technology, and that is what we wanted actually, correct? This is the reason why you have to implement both this equals and hash code method when you want to use this object, particularly in case of sets or collections where you want to do this kind of comparisons, or in the collections like map where you want to use that object as a key, right? Where map will need these methods for comparing those objects whether they are equal objects or not. And it will also need the hash code method because it will use that hash code information to put that object inside a proper bucket into that hash map, right? So I think this is why, like, because of this, you have to implement override the equals and hash code method. So we have discussed in today's session in detail why it is important to override equals and hash code method. Along with the examples, I showed you in details how. Important thing to notice here is the code works, but we get wrong results, right? Which is even worse, right? So we should not get wrong results, right? We should always get correct results. So it means that we should always remember to implement equals and hash code method when we are planning to use that objects inside collections such as set or such as map like this, right? So I hope that this video will help you in understanding this very important basic fundamental question that gets asked in many interviews by many companies for any kind of a Java development positions, right? So you should know this, you should be able to explain this in the interviews. If you are new to this channel, there is a dedicated playlist on this channel for lead code problems. If you are planning to give any coding rounds of interviews or Java rounds of interviews, you can check out. There are lots of solved coding questions on those playlists. The names of the playlist you can check is lead code and lead code solutions is one of them. It has more than 250 coding different varieties of coding problems there. The three other playlists you can check is Code Forces, CodeShep and AdCoder. All in all, you will find more than 400 different varieties of coding problems solved and explained. Many of those coding problems are previously asked coding questions by big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, LinkedIn, Netflix, Uber, Lyft and many others. You will find all different important coding questions varieties there, including BFS, DFS, matrix problems, graph problems, binary search tree problems, problems related to linked list, strings, optimization, dynamic programming, and lots of logical questions. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, this channel can definitely help you in your interview preparation process. So please subscribe to the channel. Also, if you like this video, if this video has helped you in getting clear why we have to implement equals and hash code method in today's session, and if you like the explanation of the video, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Your subscription is very important for this channel because that is the way the videos can reach to more people who need help in solving coding problems as well as understanding different important fundamental concepts of Java programming. So if you like this video, give it a like, share it as much as you can with your friends and colleagues so they can also watch these videos, they can also learn from these videos important different things that are important from coding interview perspective as well as from Java interview perspective. If you like the videos on this channel, if the videos on this channel are helping you learning something new about Java, about data structures, about algorithms and about problem solving, then please write into the comments below the description section of this video and tell us about it, how the videos are helping you. Your comments are very valuable to us. That increases our motivation to create more such good quality content, so others can also learn important things. They can also get helped in their coding interview preparation process. So comment on these videos, tell us about it, how the videos are helping you in your learning process and in your interview preparation process. Keep coding, keep learning, keep solving different varieties of problems, and thanks for watching this video.